Today we're going to look at how we can use Google Sheets to make data tables, and especially how to use formulas in Google Sheets. We'll also make graphs in Google Sheets with trend lines and error bars, etc. And then we'll see how this can all be incorporated into a formatted Google document for a typical lab. So we want to take a look at how we can use Google Sheets. It's a really effective tool for our data tables and making scatter graphs and just generally helping us do our labs quickly and effectively. So what I've got here is some student data as they wrote it down. It was a pendulum experiment. I've simply put it into Google Sheets. The student varied the length of their pendulum from 40 to 100 centimeters, and say at 40 centimeters they did 3 trials. So this is all their raw data. Now in your data you want to make sure that you have the right number of significant figures, and all these times here we're done with a stopwatch, so they're to the nearest hundredth of a second. So all of these numbers here, and you can see a few examples, this one here and this one here, that aren't written to the right number of decimal places. So what we can do here is highlight all of those numbers and then come up here. This gives you 1 extra decimal place. We don't want that. We actually want 1 less. So this would give us all of our numbers in the second decimal place. And we should likely do the same thing here. These numbers here, right now they're written to just 1 significant digit. It's likely that these measurements were made to the nearest millimeter, so they should be written to 1 decimal place, 1/10 of a centimeter. So they should look more like that. Now what we'd like to do is calculate the average over the trials. What was the average time it took to go back and forth? And we had to be a little bit careful because these times here I can tell were done for 5 periods. All of these were 5 periods. So I'm still going to take an average over these 3 numbers. So I'm going to call this average for 5 periods. I'm not too concerned about these headings here. I just want to write them well enough that I can remember what each column represents. Later on I'll make that more effective. So if I want to calculate an average, we can save a lot of time if we use a formula. So if I go up here, if I just click in the box here, I really get my icon in the formula in the address bar up here. And if I make an equal sign, that tells Google Sheets that I want to make a formula. Right, and it's just going to be an ordinary average here, so I'm going to use the command term average, and I want to calculate the average of these 3 numbers here. So I just highlight all 3 of them. So those are cells B2 to D2. In that bracket, press enter, and I get the value. The average of those 3 numbers is 6.66. But where Google Sheets and formulas become really effective is if I now highlight that cell and wave my mouse cursor on the bottom right hand corner, you'll notice it comes and becomes a cross. Once it becomes a cross, you can drag that down, and you're really dragging that formula down for each row. So these are all the averages for 5 periods. Next thing I'd like to do is calculate the uncertainty over 5 periods. And I'm simply going to do that using max minus min over 2. So I'm going to look for the maximum of those 3 numbers. It'd be 6.76. I'll look for the minimum, 6.54. If I subtract those, I get the range of values. Divide by 2, I get the uncertainty. So once again, don't forget to put the equal sign in for a formula. You're going to calculate the maximum, that would be this one here, of these 3 values. So this should come out to be 6.76. Then you want to subtract the minimum. Here's minimum over those same 3 values. That should come out to be 6.54. Now be careful here. If you just write divide by 2, what it's going to do is take the minimum and divide it by 2 and then add that to the maximum. What you really want to do is go find the range first, maximum minus minimum. So you need to put brackets over that numerator. Then press enter, and once again you can pull that down as a formula and get all the uncertainties over 5 periods. And here you're seeing different numbers of decimal places. These are uncertainties, so I usually just go to one significant figure. So I'm going to reduce that to one significant figure here. What I can see in these uncertainties is that they're kind of bobbing around, but there's no trend to them. They're not getting bigger and bigger and bigger. So what I'm going to do is write down a typical uncertainty. So my biggest value here is 0.3. There's lots of 0.2s, and for a typical value with uncertainties, I like to err on the large side rather than the small side. So I'm going to take my uncertainty to be that largest value of 0.3. I use a bit of gumption here. I don't always just go with the largest value. Sometimes I think the largest value is a bit of an outlier and doesn't represent the typical uncertainty. But in most cases, I'll simply go with the largest value. Now, I don't want to plot the length here against the average for 5 periods. I really want to plot the length against the period. So I'm going to do a column here for the period in units of seconds. And once again, I'm going to use a formula. It's going to equal whatever this number, whatever the average for 5 periods was, divided by 5. And then once again, I can pull that down and get all of my periods. Once again, I can see that there's too many decimal places here, so I'm going to reduce that. And for now, I'm just going to keep the same number of decimal places as I have for 5 periods. And then I'd like to have an uncertainty in the period. So when we multiply or divide by a constant, we keep the same percentage uncertainty. So whatever the percentage uncertainty is for 5 periods, it should be the same as here. Which means that basically you're going to take that typical uncertainty, 0.3, and you're just going to divide it by 5. And I'll make that an equal sign as a formula again. So my uncertainty in the period 0.06, and that's going to stay the same for all of those because I'm using this typical uncertainty value. Okay, so now let's make a graph for our data. And my first step is simply going to be to highlight all the data and then say insert chart. I'm not going to include this typical uncertainty of 0.3. So insert chart, and we immediately get a graph. I'm going to make it smaller just so that I can see my data and my table at the same time. And if you click on your table, you get this chart editor come up. Under setup, that's where you tell Google Sheets, okay, this is the data for my x-axis, this is the data for my y-axis, etc. And then the customize, that's where you do things such as adding trend lines or adding error bars or adding your chart titles, etc. First thing we have to do is to choose what style of a chart that we want or what type of chart that we want. In any of your science graphs, any of the graphs that you do with me are not going to be a bar chart. They're always going to be scatter graphs. I always want scatter graphs. So if you come down, it's quite a ways down here to scatter graph, and then we've got this kind of crazy looking graph that we're given automatically. If I look along the x-axis here, those are the lengths 40, 60, 80, 100. So my x-axis here is chosen correctly. I'm not going to change that. But here, the series, that's really your y values. You can see that I've got a whole bunch of series. The only one that I really want is this one here. I want to plot the period on the y-axis versus the length on the x-axis. So I'm going to get rid of all of these except for the one that says period. and now we have more of what we're expecting for a graph. It says here, use column A as labels. This is kind of awkward wording here. It says use column A as labels, but those are simply your values along the x-axis. So as a default, it says use column A as labels. So it's going to automatically take your first column to be your x values. That's all that that's saying. If I click that off, then the first column becomes really a y value and you don't have any x values. So put that on. Use row 1 as headers. Well, that's true. Here's row 1 and those are headers, so that we want to keep. So now let's move on to customize. And we'll start with the chart axis and titles. Vertical axis title, that would be the period, and the units were seconds. The chart title, I'm simply going to call that the period of a pendulum. And finally, the horizontal axis title will be the length of the pendulum, and that would be in centimeters. So now I've got my titles. Let's scroll down a little farther. If you want, you can make changes to the font, etc. The words look too big here, but when I expand the graph, of course, they're going to look more normal. So let's go now to series. This one's very important. I would like to add error bars, and you'll remember that I used a constant value of 0.06 for my uncertainties. That was the kind of the typical value that I used. I don't want data labels. Data labels are just putting the value, the y values on each of the points, and I find that more confusing. I do want a trend line though. For now, I'm going to leave it as a linear trend line. Turns out it's not really linear. And I would like to label it with an equation. So right now it's a linear equation. And that's basically all I need from my series menu. I'd like to now go on to my horizontal axis, because you'll notice here that I'm going from 40 to 100 in the lengths, and I'd really like to go from 0 to 100 in the lengths. In nearly all the graphs you do, you want to include 0, 0 as a point. Now there's one more adjustment that I'd like to make. I know for a pendulum that if there's no length, there's no period. If the length is 0, the period's 0. So I'm going to add another point to my graph. So I'm going to insert a row below, and I'm going to add the point 0, 0. So now I've got another point on there. And now you can see that this straight line graph isn't so great. So I'll bring up the chart editor again, customize, and series. And instead of doing a linear fit, turns out this is supposed to be a kind of a square root. Square root is an example of a power function. Power functions are like x to the 1, x to the 2. In the case of a pendulum, the period is supposed to go as the square root of the length, so the power is really 1/2. A square root is the same thing as a power 1/2. So, and you'll notice here in that best fit, the exponent came out to be very close to 0.5. Now another thing that I often do is to put some more grid lines, and that comes down here. Grid lines, the vertical axis, so those would be the lines running across. I'd like to have, say, 5 lines in between 0 and 0.5. So my minor grid line count is going to be 5 there. And then I'll look at the horizontal axis. I'd like to also have 5 lines coming up here. So I'm going to make that a 5. So now we've got a fairly finely tuned grid system there. And it's going to look a lot better once we make our graph larger. So we now have a fairly good looking graph. The only thing I don't like is this negative 0.5. Of course, we can't have a negative period. So I would like to change my minimum and maximum values for that y-axis. So if I come back to the vertical axis, the y-axis, I can put in a minimum value of 0 and a maximum value of, say, 2.5. So now I could just make it a bit bigger, and I've got a pretty good looking graph now. And we'll be able to cut and paste that into a Google Doc, or we can link it to a Google Doc. Once you have your graph and table done, you can open up the lab template that I've given to you. It contains the standard structure that I'm expecting you to follow. And in brackets here, you can see that for each subsection of the lab, there's some more detailed instructions as to what's expected. Once you're finished writing your own work here, then of course you can get rid of these brackets. They're just meant as a guideline. One of the things that you're going to want to do is, and I'll show you at a later date how to do this well, is to make a sketch graph, a graphical prediction as to what your graph is going to look like. And the easiest way to do that is to insert a drawing. So you're going to do a new drawing, say, using Google Draw. It's going to be just a sketch graph, so it doesn't need to have numbers on it. You're just saying what the shape of the graph is going to be like. So perhaps you think this is going to be the shape. You might add some annotations here. The annotations, together with your explanation in the text, should be enough to give the reader a clear idea as to how you made decisions to make that particular shape. Save and close. Now you can see the sketch graph right there. And next, what you want to do is make a data collection table. And in most cases, that's basically going to be done for you if you just highlight your data table from Google Sheets. So you can just copy that and then come back and paste it. And they'll ask you whether you want to link it to a spreadsheet or not. I usually find it's advantageous to link it to the spreadsheet. What that does is if you make edits in the spreadsheet, they will automatically show up in the table. So typically I do a bunch of edits to my table here to make it appropriate for the lab itself. So if I want to do a row above this top row, I put my cursor in the top row and I go to Format, Table, and Insert Row Above. So now I'd probably write these words out properly, length, and I'd give the uncertainty plus or minus, say, 0.2 centimeters. All of these values here would be the time for 5 periods, and that would be measured in seconds. And this would be my trial 1. And I won't do all the changes here. This would be my trial 2, etc. Anyways, I don't want to spend a lot of time just showing you how to put the table headings in. You should be able to do that yourself. I don't think Google Docs is very good for editing the tables up here, so I'm not sure. Maybe you can figure it out. I don't know how to get rid of these lines here so that all three trials would go under one box here. Once we're done and we've got our table all edited, it all looks great for the document, then we can go back and get our graph. Here's our graph. Click on it and then edit, copy, and paste your graph. And once again, it can be linked to a spreadsheet. And then you just want to fill in the rest of the template and complete your lab. And that's all for today, folks. Thank you very much.